It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
You live in a spaceship, dear.
So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 251 of Science on Top. Today is Sunday, 11th of December 2016. I'm Ed Brown and I'm joined by Dr. Shane Joseph.
Hello.
Penny Dumsday.
Hello.
And Lucas Randall.
Hi.
This is our second last show of the year. And today we'll be talking about using ancient astronomical records to determine Earth's rotation, how tripping on mushrooms could help with depression, and how Germany may be on the way to creating a star inside a jar. Not my phrase. But first, a study that mixes astronomy with archaeology. And by looking at astronomical records from 720 BC to 2015 AD, this study's authors have found a small inaccuracy in modern calculations of the Earth's rotational speed. Penny, this is looking at records of eclipses, is that right?
Yeah, it is. And this is the kind of thing that I absolutely love because it's pulling together all sorts of different fields of study: archaeologists, historians, astronomers, geophysics, bring it all together to try and see, to get a picture of what's been happening over the last couple of thousand years. And the outcome is that Earth isn't slowing down as much. So the Earth's rotation has been gradually slowing down, I guess, since it started rotating. And I think in dinosaur times, days weren't 12 hours long. They were like 7 or 8. I might be wrong. Not 20, you know what I mean, like the day. Anyway,
daylight,
daylight would have averaged a lot less. So, but everything
they didn't have daylight saving either because they were worried about their fade.
I know, the fade's a curtain.
Yeah, they had it right, the dinosaurs. They really did.
You're not even a Queenslander. I don't know why you're saying that.
Anyway, what this study's done is it's looked through all sorts of different records, like for records of eclipses and other things. And I have to confess, as I told Ed before the show, I tried to read the actual paper and it was a bit above my head. So I think I'm just going to give the big picture quickly and then leave it up to anyone interested to look it up themselves.
Yeah, we'll have links in the show notes if you want to do your own research.
So Chinese, Babylonian, Islamic, Greek, all of these lunar eclipses and solar eclipses were able to be used, and sometimes the records were very basic by an untrained observer, but they made the point that even that kind of person could recognise the difference between a full eclipse and a partial eclipse, and they'd say stuff like, oh, the sun was covered and it looked about the same as a 3-day moon, which can give a pretty good idea if you have the date and how much of an eclipse, which gives you an idea of where the Earth was in relation to everything else in space at the time. And I hope you can see how I'm getting a little bit confused. But what blew my mind, though, is that it's not like calendars have been consistent that whole time, that record keeping was not necessarily precise. You know, there's changes between solar calendars, lunar calendars, Gregorian calendar, Julian calendar, conversions in between them. And I just think the amount of work that would have been done to create a data set from the ancient records and to figure out, well, what is relying on each other thing to validate the data, if you know what I mean. So, like, we think that the Babylonian calendar relates to this time in our calendar, but then why do we think that? So I just think this is an amazing study. It's really fascinating that these records show that the Earth might not be slowing down as quickly as we thought.
We thought it was slowing down by 2.3 milliseconds per century, but with this new study, it's only 1.7 milliseconds
1.7 milliseconds. Yeah. Which it makes us think that maybe our model could be modified, that we are looking at some aspects a bit too much, or that there's something that we're not factoring in. And it blows my mind that, I mean, look, I don't know, again, I'm not qualified to really talk about it, but that you can use those records to get data down to the millisecond, because I'm pretty sure that the Romans and the Babylonians were not measuring stuff, to the millisecond.
No. But also, I mean, an eclipse can last anywhere from 1 minute to 4 minutes to 7 minutes. So you don't need that amount of precision to know. You can really, if you know it was on that day, you can then correlate the rest of the calendar to match up with that. I also think it means that we can use astronomical data as kind of a check on how we do historical analysis and how we look at ancient calendars. We can go, oh, well, they've got an eclipse on this date. We can look at when there was probably an eclipse through our own calculations as a check on our understanding of their culture and their calendar. So it sort of works both ways. It's very cool.
It's a nice little
I like the implications that they drew as well in the ABC story. Because they were talking about what could have caused the change, because maybe the models with the data are more or less correct, but if the observations don't make, as Penny said, if the observations don't match the models, then the data feeding the model could be wrong, or the model itself could be wrong. But if they tweak the inputs to consider other possibilities, such as the last ice age. The last ice age is one of the possibilities for why the rotation rate may have changed, because during the ice age you get basically you get a lot of redistribution of weight around the globe, because obviously you get glaciers forming. So when glaciers form, you end up pulling ice from the poles down, towards the equatorial regions, because the whole planet sort of starting to turn into a snowball. And when that happens, it's the old analogy is an ice skater pulling their arms in or putting their arms out. That change in the balance or the distribution of their mass has an effect on the spin rate. So moving the mass around can make the globe slow down or speed up, and that could well be one of the primary differences that's not considered within the models. And we know now, even there was a story doing the rounds not too long ago about the massive dam that was built in China. I can't remember the name of it.
Three Gorges Dam. That's
it. Yes, it's a very Chinese name. So that's basically is also having an effect on the spin rate of the Earth, albeit very, very small rate, or very small change, I should say, because there's suddenly a whole lot of water concentrated in a spot where it wasn't before. So it's amazing how these things have an impact. And I know on the show we've done stories before about how even certain earthquakes can have an impact on the spin rate and thus the length of our days. So it's very cool. I mean, we've discussed this recently as well with regard to some of the theories about the slushy ocean on Pluto and so forth. All of these events and the redistribution of mass, particularly water, which is quite heavy and heavier than ice, can have an impact on the rotational rate. So very, very cool. And I think it's just a matter of more inputs to the model.
More data needed, as always.
Yeah, but it is as Penny was saying, the really cool thing is just that they're able to go back into these records and these observations, and although you're right, the ancients didn't have the sorts of clocks. They didn't have atomic clocks. They didn't have laser beams or sharks with freaking laser beams or any of that stuff that we enjoy so much now. So they didn't have the accurate clocks, but they did have incredibly accurate astronomical observations, and that's where such a huge part of our knowledge of astronomy comes from, is that time, because it was all the foundations that were laid back then. So I mean that's really the astonishing part is just the rich observations that were made by so many different cultures over such a period of time can help us dial in on things like, as you said, the length of the year, which you can then break down into the smaller chunks and so forth. It's really cool.
The other thing I liked about this article was that they've actually published all those data sets. So they've made them into nice tables that I'm sure are meaningful for people who, can understand.
I think we can all agree tables should be meaningful for everyone because they're awesome. That's
they
just
are,
all I'm
but
say. Love data.
And look, if I could click through 2 clicks to get to this table, anyone can. And I just think, if nothing, even if all the interpretations change because of this and that, just simply having that data set of, all these different eclipses, because that's a huge amount of reading to get these records.
Yeah, it's very cool. I wasn't sure, because it was quite a brief article, and I didn't delve into the paper on this one either, but I wasn't quite sure how the data was compiled. Did it involve a citizen science thing, for example? Because this would have been a perfect citizen science project. This is like there's projects that I've participated in for example, converting maritime records into, or digitizing maritime records. So, there's a whole lot of logbooks from ships around the world in various, time frames that have been scanned and going back hundreds of years. And those observations are actually very, very worthwhile and very handy for, tracking climate change, for example. So, there's citizen science projects going through that sort of data and keying it in, converting it from handwritten stuff that they're seeing on screen into keying it in into fields that can then be put into tables and that sort of thing. So it'd be cool to know. If anyone does know, I'd be very interested to know how this was all digitized.
Yeah, look, I don't know. A couple of equations popped up quite early on in the article, and I stopped reading.
Fair enough.
I have that same response to equations. That's all right. I think just what I like about this is just that interdisciplinary approach to it. It's just you've got your history, your archaeology, your astronomy, your geophysics. It's all coming together for one study. It's very impressive. But let's move on now and talk about a small section of a dinosaur's tail that's been found in a piece of amber for sale in a market in Myanmar. Shane, the tail is amazingly well preserved and, well, it's feathered.
Yeah, it is feathered. As we've talked about, I think, on this show before, it's fairly well known now that dinosaurs probably were, at least, a lot of them were feathered. And even though that sort of seems to go against everything we know about dinosaurs and everything we see in, modern art and culture
everything
about
that Jurassic Park teaches us about dinosaurs.
Everything, yeah. I mean, even the latest Jurassic Park movie didn't have feathered dinosaurs, as far as I'm aware, or did it? Did anyone see it? Because I didn't.
I didn't see it, but I would imagine that feathers would be quite costly to animate. And
it had Chris Pratt. Remember that? He didn't have feathers. Actually, he might have had feathers. I can't be sure about that.
Maybe he did. But it still seems like it doesn't really sort of come across as a common thing. But if this little fossil is anything to indicate, this is definitely a dinosaur tail. Like, they found other birds from the era, I think from the Cretaceous era, and they're not dinosaur feathers of these other fossils I'm talking about. This is definitely a dinosaur tail. It comes from a little, I think it's like a chicken-sized dinosaur that is actually kind of related to velociraptors and T-Rexes as well, but not the same, obviously, because that would be cool. T-Rex-sized tail in a piece of amber.
They're related. It's similar to it. And we should point out, when we say this is from the Cretaceous era, we're talking 99 million years ago. So just to give some context.
And the actual piece of amber is only about the size of an apricot, I think they said, so it's very small. What's really cool about it is that, so a lot of these, apparently, with these pieces of amber, like, there's a big trade that goes on with these pieces of amber, and apparently, if it's a really nice piece of amber with a really nice fossil inside it, you can get a lot more money for it. Apparently, with the preparation of this piece of amber, it was cut like a cross-section across the tail. So scientists, the guy who found it, and then when they examined it, they could see there was a nice little cross-section of the tail that they could look at as well. So, in a way, it was kind of fortuitous. So using this cross-section, they figured out that, it's basically a presentation feather. It wasn't a flight feather. It definitely belongs to this dinosaur. And it just gives us a better idea of how these things, developed. And it's another sort of link in the chain, the so-called missing links of feathered dinosaurs to birds, etc. So it's really cool. Yeah. And in this piece of amber, there was also, like, I think an ant or something that was preserved as well as a bit of plant debris. So it's like a little snapshot of what was there at the time when this amber came down and engulfed these creatures. Yeah.
Would actually be interesting to see if there's anything that we can learn from the ant as well. I mean, how much have ants changed over 99 million years? Or are they more or less the same?
I think they're as far as I'm aware, they're more or less the same. Like
I can't see there being many evolutionary pressures on it, and it looks exactly like an ant to my untrained eye.
But I think insects are fairly. I think insects have sort of kept. They haven't really. Progress is the wrong word, but they haven't changed much over evolutionary time as far as apart from in size. I think I think some insects back in the Cretaceous and Jurassic periods were much bigger than they are now.
Yes,
yeah,
simply because of the oxygen levels.
There's more oxygen. Yeah, exactly.
Yeah,
freaking arachnids. Oh my god!
Oh man, this is why if there's ever a time machine developed, I will not go back there.
Not there.
Sorry,
no, thanks. You can
I don't want to see a dragonfly that's the size of a person.
Right.
Sorry, I just don't. but this is actually, this is actually interesting though, because I remember I was on on my Facebook feed, someone, a mutual friend, posted this, and he's a bit, he's a sort of amateur skeptic, or an amateur scientist, whatever you want to call it. He says, I don't see why we can't clone this. If it's intact. And I said, look, dude, it's not possible. Like the half-life of DNA is
99
about
million years ago.
The half-life of DNA is about 500 years.
Yeah.
No matter how well you preserve it, so it's just not going to be enough DNA in there to clone it. So sorry, it's a nice idea, and Jurassic Park was a really, really nice idea, but no, sorry. It's not going to happen. But what it does give us is a really nice snapshot of the place. Why
does DNA break down, though? I mean, if this is sealed in amber, so there's no other oxygen or anything for it to degrade from like a bacterial degradation process, is it just because it's a fragile molecule and it breaks down?
It's a fragile, long, complex molecule. The reason DNA the DNA does degrade in our bodies, the difference is that our body basically keeps it maintained. So, the blueprints of it are maintained, they're copied, they're passed on to cell. But as soon as you leave it, it just naturally breaks down. It's just it's a very long, complex, fragile molecule, and it's not going to last in its structure like that. Barring, I think, very, very, I'm not sure what the preservation of molecules is like in amber, but, I mean, I think it's good enough to preserve megastructures and things like that. But as far as long, complex, fragile molecules, no. Probably not. So
fair enough.
It might be better than 500 years half-life in amber, but still it wouldn't be good enough to preserve.
Even if it's only 1
million, for 900 million years,
it's still not going to be useful in this case.
Yeah. No, not in this case.
Interesting. Lucas, nuclear fusion, as opposed to our current nuclear reactors, which use nuclear fission, is the holy grail of physics research. Almost limitless energy, no toxic byproducts. Well, the Wendelstein 7X project in Germany appears to be well on the way to making substantial progress in that regard. Do you want to give us some background info on this and an update on where they're at now?
Sure, yes. First of all, Wendelstein. Am I the only one who thought of Wolfenstein?
Yes.
Probably.
No, you weren't actually. So, yeah.
I would totally want to see a first-person shooter set in this nuclear reactor.
Yeah.
That would be cool.
I agree. I reckon it would be the same. It would have those stone walls, and you'd have to look for,
there'd
anyway,
be dogs.
Sorry, off topic.
Anyway,
yeah. So I guess first of all, what is the problem with fusion? The problem with fusion. Well, the problem with fusion is basically it's really hard. We have done fusion before. We can fuse atoms. We have that power. But in order to do it, it takes a huge amount of energy to not burn up the thing in which the reaction is taking place. So in terms of producing power, it's kind of, it doesn't pay off because you end up pouring in a lot more energy than you actually get out of the thing. So there's been, attempts to build functioning fusion reactors for experimental purposes, none that have actually gone, with the intention of plugging into the grid. But it's been, it's a science that goes back quite a long way, a few decades. So it's been one of those things of these incremental gains. And until pretty recently, the best we could do was we're almost approaching that zero sum where we were putting in we were getting out almost as much energy as we were putting in. So still not worth doing on any kind of scale, but it was it was a good sign. The real problem with this is actually the temperatures that are required because the sun and all stars, this is what they do. They fuse atoms. Our sun typically fuses hydrogen atoms and it produces helium, and basically that's the reaction that maintains the sun. So that's great, but the sun's really big. So the sun's about 99% of the mass of our solar system. So because of its size, not only is it immensely hot in the middle, where we're talking around 15 million degrees Celsius in the middle in its core, but it also has massive pressures just because of the gravitational force pushing down onto that area, and that's actually why it's so hot. It's the gravitational pressures that are causing that heat. So the fusion takes place as a combination of the temperature and the pressure. So they're the two elements that you need. Now, we don't have any way of producing that pressure on Earth. So what we have to do instead is produce temperatures that are higher than the temperature at the core of the sun.
Is that all?
That's not easy. So we're talking, sun around 15 million degrees Celsius in its core. Surface of the sun, just for reference, is only about 5,500 degrees Celsius. Not that hot. You kind of, I mean, it's hot enough to ruin your meal, but it's not, when you compare it to what a lot of people think, the surface of the sun is not that hot. But in order to
but you will fry.
Oh yeah, for sure. There's no coming back from that. But in order to achieve fusion on Earth, we need temperatures of sort of upwards of about 80 million degrees Celsius. So 15 in the middle of the sun, 80 million is what we need, roughly, or more.
Sorry, Luke, what's the sort of pressure we're talking about with the sun? Like how many atmospheres or whatever you want to have?
I don't have it on hand, but I'd say lots. I don't know exactly off the top of my head, but really, really lots. we're getting to the levels basically that your atoms are squishing together.
Okay.
Go ahead.
It's 150 times the density of liquid water at the centre of the sun. I don't know if that's helpful.
Right. That doesn't really help me.
As a reference goes, I don't know what to do with that information. I'll just put it here to my left.
Pressure, core, sun. Let's have a look.
Thank you, Google.
Pressure at the centre of the sun ranges from 3.4 times 10 to the power of 8 to 2.25 times 10 to the power of 11 ATM, depending on the source.
So there you go.
The ATM
so lots of
atmospheres. Yeah, okay, that's atmospheres.
Of course,
how many atmospheres that? Yeah, so it's a lot. Okay,
so lots. So lots of
I'm
zeros.
glad we've got that established.
And I think I said at the
beyond our comprehension.
In answer to the question, lots.
Yeah.
So we now have a figure to wrap around lots. So that as I said, the issue here is that we can't produce those those conditions exactly. So what we can do is we can play with the other lever, which is the temperature one. Now the problem with producing something that's almost 100 million degrees is it tends to melt everything. That's one of the cool things about high temperatures. You can melt stuff with it. So not much really sort of will in fact nothing is going to be able to contain those sorts of temperatures for very long. So what we've known for quite some time is that we have to do this basically with magnetic fields. We need to use magnetic fields in order to contain the plasmas, because the antimatter is going to be in a plasma state at that sort of temperature. We need magnetic fields that can contain the plasmas, and the sun does this. We actually see this in action when you see sunspots forming on the surface of the sun. What you are actually seeing are the plasmas wrapping themselves around areas of magnetic fields. Yeah. And even so, so often you'll actually see a filament flick out from the sun, which is what can cause a solar flare or even a solar storm, which could be really devastating to civilization. So there's a lot of magnetism that's involved in the sun doing its thing. So magnetism is really the key to this. So what has happened here and what has changed is this particular team, who are based at the Max Planck Institute for Plasma Physics, they have produced this technology, which is it's a few along. There's been a few predecessors of this technology by I assume the same team, or certainly by the same organisation. It's called a Stellarator. I love it. It's awesome. It's a Stellarator at Wolfenstein. It's great. It sounds like you'd have to open one of those panels to get the Stellarator.
It's definitely the secret room. Yeah.
for sure.
I'm just imagining the big boss Hitler with the machine gun arms. And
you
Mecha
can only take him
Hitler.
out with the Stellarator. That's all you can.
Yeah,
use.
with the Stellarator. Oh, awesome. Yeah, anyway.
So this Stellarator, basically it does it produces these magnetic fields that are required in order to contain those sort of temperatures, or the plasmas that are producing those temperatures. So its approach to this is to basically supercool these coils. So they've got these superconducting coils. Another thing that has been long, and still is, superconducting materials are another holy grail in physics. But we're getting close to that. So they've got these superconducting coils, or almost superconducting coils, that are cooled down to near absolute zero, which is cold, and then at those temperatures, they're able to produce these magnetic fields that are required to stop all the plasma heated to sort of over 80 million degrees Celsius from touching the walls of the containment chamber, and that's really the key. That's where they're at. So they've already produced the plasmas in this thing. They did it, I think, at the beginning of this year, or late last year. I think it was turned on in December last year, and they've done earlier tests where they got the plasmas approaching those temperatures. But now, but it was only for an instant. Now they're able to they're basically at the point that they can produce these fields. So the next step is to do it. They know they can produce the fields. They know they can produce the plasma. Now they've got to do them both together, and that's the next step in achieving this very, very, very cool, and possibly something that will save civilization in many ways, because we're rapidly reaching a point of having overpopulation issues in the world that are going to cause significant energy crisis. And an energy crisis means right across the board, things like food production suffer. Pretty much everything we do is very wrapped up in energy. So we need to be able to produce a lot of it, but we also need to do a lot of it without pouring carbon dioxide into the atmosphere. So the waste product from this type of fusion is helium, which incidentally we only have finite amounts of on Earth, so that's kind of cool. We can have lots of balloons. So that's
lots of MRIs as well.
That was just as I say, it is just an incremental step, and this obviously has to be scaled up, and they haven't done it yet. They just know that they're ready to. So there's a lot still that needs to fall into place for this to happen. But what is cool is this is actually comparatively quite a big step from what has been happening over the last few decades, and that's really, really cool.
When they do start up, is there any chance that this will rip a hole in space-time and cause a black hole like it was feared that the Large Hadron Collider would do?
Exactly the same amount of no chance.
I think the most things that will happen here is that there'll be a big explosion.
Yeah, that could happen. Oh, that could totally happen. Yeah.
So that would be tragic, but it wouldn't be world-altering tragic.
But unlike nuclear fission, when you're splitting atoms, that nuclear fission can cause a runaway chain reaction. So that's one of the cool things about nuclear fission is once you start the process, it maintains itself. Nuclear fusion doesn't. It needs the constant temperature.
It needs the heat.
To continue going. So once you flick the switch off, it stops. So you don't end up with any concerns about this sort of meltdown and nuclear waste and so forth, because it's not producing any; it's just producing helium. We'll all just have really high voices for a while.
Well, that's
but you wouldn't want to be there.
Fun experiment.
No, but this is really cool. This is as Lucas said, this is the holy grail of energy production. I mean, geez, if they can do this, all of a sudden, the consequences of this would be. On a global scale, this would be pretty mind-blowing and catastrophic to a lot of other industries.
Well, the one that people may have heard of prior to this is cold fusion, which has been the other holy grail, is trying to do exactly this, but without requiring those immense temperatures. Because if you can do it, cold fusion, So that's what people may have heard of a lot in the past, and that's just not likely to happen because it's what we understand. It's just physics don't work that way.
Exactly. If you need intense pressure and intense heat to fuse atoms together to release enough energy to make this a self-perpetuating thing, cold fusion doesn't seem to make a lot of sense. Even to my physics,
it's that same.
Even to my physics sort of done brain, it doesn't work.
To do without the heat, you'd have to do a lot of pressure, and we don't have any real way of generating immense pressures just yet. So,
Well, no.
very
When you
interesting.
squeeze things down, they get hot. So,
Well, yeah.
Yeah.
All right. Let's finish off, Shane, with a small study done at the Johns Hopkins University that could give cancer patients suffering from depression and anxiety some hope. It suggests that just a single dose of magic mushrooms could improve their mental health for months. Tripping on magic mushrooms for depression and anxiety.
Yeah. Yeah, look, I really like this article. I think in the past I've heard about this so-called, therapeutic benefits of psilocybin. I think that's how you pronounce it. Psilocybin, which is the active ingredient in magic mushrooms. And now, obviously, we've all heard of magic mushrooms and the amazing trips they can give you, and also the horrible side effects they can give you if you pick the wrong mushrooms. But like a lot of these drugs, it's not really well understood how they work because they're contraband, but also because they haven't really been studied. Now, in this case, they got cancer sufferers. Now, as you can probably imagine, people who are undergoing cancer treatment and who may or may not be terminal are generally, they can suffer from fairly bad depression and anxiety, for obvious reasons. They're facing their own mortality. And this article, which Ed will link you to in the links, is a very nice little piece, and it goes through the experience of one of these particular volunteers, and how the things that she was going through, her mental state, and how her son basically said, "Well, why don't you try this study?" And then it details her trip, which they gave her like a quite refined version of magic mushrooms, like in a little capsule. And she had an amazing trip, and she saw she saw lots of things.
Did she see the Ball Collective or something? I read
she saw the Ball Collective, and she saw the crab, the astrological crab, whatever that is.
Cancer, the crab, the zodiac sign.
Is it Cancer? Yeah, but, so she basically had a wonderful time. Well, what's and this is all very funny, but what's amazing about this is that they did this study. They did this in a quite controlled way. They gave these volunteers, I think, it was 51 volunteers. They gave you a low dose of the psilocybin as a control, and then a high dose 5 weeks later. And then they followed it up, I think, 6 months later. And what they noticed was that in this period, after this high dose, the self-reported level of anxiety and depression lessened quite dramatically in most of the patients. We're talking 78% of people. Now, this is compared to when you use standard antidepressants like SSRIs or selective serotonin reuptake inhibitors. So, based on SSRIs are a very well known antidepressant drug, and they don't perform that well in this group of patients. 40% of patients said that this helped them, which performed about as well as the placebo. So, it's a definite difference, and this is not. I think with these SSRI, when you give SSRIs, you don't just give in one big hit. It's like a dosage. It's a slow dosage thing. But that wasn't as useful as this one hit of magic mushrooms, which was then followed up 6 months later. Now, obviously, this isn't a panacea for cancer. This isn't like this is cured my cancer. No, this is basically dealing with the horrible feelings you get when you are diagnosed with cancer, or any incurable disease. What this got me thinking, and I was thinking, well, would this be useful in other kinds of depression? Because we know that there's a fair bit of controversy about the way that antidepressants work, and a lot of the times, a lot of these brain medications, people don't know how they work. They haven't figured out the biochemical pathway. I think even SSRIs, they don't know the exact route, the exact biochemical route that it takes to do what it does.
I think that
and I don't know how,
problem with
and I don't know how psilocybin works either.
We don't know how antidepressants work very well. We don't know the pathway that they use all that well, and we don't know how the psilocybin is working. We don't know anything
at all
about that.
Yeah. Well, I think they seem to think that it, there's evidence that it sort of calms the prefrontal cortex, which is a place of increased activity where depression is known to occur. So, but apart from that, I think they don't know much at all, and that's. It's kind of... It is
worrying, though, isn't it? Because it could be increased activity because the brain is trying to mediate or take other measures to balance, and I'll just turn that off. You just don't know until you start playing with it.
I suppose in this case, like we know that. I'll be perfectly frank here. I suffer from depression, and I know that it's I would do anything to turn my brain off in these cases sometimes, and it doesn't matter if it's it doesn't matter if my depression is an evolutionary result of whatever.
Like it's really actually greatly adaptive for survival. Yeah. Yeah,
that's great and all, but it makes me feel horrible. So I'd like to be able to turn it off. And in this case, if a drug like this does that in one little hit, now, but I'm not sure exactly. Like, I would love to know if this would be as effective for standard clinical depression, or bipolar depression, all that sort of stuff.
This is also a very small study. Yeah, this was only done on 80 patients, which is a lot for this level of study, I think. But in terms of it being a large-scale study or anything, it's more just a proof of concept. It's just saying that there's definitely something good that happens when we do this. Now we need FDA approval, we need more grant money, we need more patients, we need more research, which is fair enough. And this is where the other problem comes in, because as we all know, the United States has just elected Donald Trump in. Now, there's a reason for this. There's a reason I'm saying this. His head of the Justice Department, his pick for the head of the Justice Department is a very staunch anti-drug person. So the problem with psilocybin is that it's obviously a contraband drug. To get FDA approval to use these in trials, or to even possibly use this as a therapeutic, is a very, very hard road. So when you've got a political climate where this sort of thing is not encouraged, this could make things a lot harder for researchers, and a lot harder to get this sort of work done. It's a bit of a worry. That's a depressing note to end an otherwise uplifting story on. I feel now we all need to take a few
use some mushies to feel better.
Sorry. Yeah. But that being said, like it's if there is some sort of if there's potential in this treatment, then I think this will come through.
It's exciting study, no matter what. We don't need to speculate too much just yet. We can just say this is an exciting proof of concept. Let's see where it goes. Very cool.
I must say, though, just judging from her 6-hour trip, I'm fairly keen to put my name.
Dude, same. I'm not even. I'm not a big drug person, and yet I kind of want to try this.
Yeah.
I'm actually interested. I'm actually very interested in because obviously this is a self-reporting study. Like people will say how they felt afterwards. So there might be a bit of unreliability here, but the fact that it was 2 big hits rather than just a sustained dosage, it's interesting. Like it's not. It sort of goes, from what I understand anyway. It's contrary to your normal clinical study, really, for this sort of treatment anyway. So
they likened it to a kind of inverse post-traumatic stress disorder, where you get a really good positive experience, and that lasts for months, and it flips your way of thinking, I guess, around for months after that.
Yeah.
Very cool.
Yeah.
Definitely.
And also, on a nice... sorry, I was going to say, and also on a nice note, these people who are in this study, a lot of them have had their lives positively changed for the better, regardless of whether they survived cancer or not. It's improved their outlook on life, and however long they have left. In this case of this one person who they followed through the study, she was very, at the start of the article, from what I read, she was in a really, really bad place.
Yeah.
But then by the end of it, she's like, well, I know I haven't got very long left, but I'm going to just live life to the full. I'm going to do things that I haven't done before. So, if that's a positive to take out of this, well, there's definitely that.
Absolutely.
I must have, reading this story of the patient Vincent, and she's saying here she's since taken an art class. She found herself making paintings that included themes from some of her psilocybin-induced visions. Past feelings of anxiety and depression have not resurfaced, and she's feeling she's tapping into something bigger than me. Authors and artists have, said similar things about their use of certain things like mushrooms in the past. So it's it makes sense, I guess, in that respect. But it would be frustrating to think that it wouldn't be studied any further, because of its classification, at least in the US.
No, it's a very cool study. hopefully we'll see some more research done in that area. But I think that's our show. If you want to get any more information, you can check out the website, scienceontop.com/251. And from there, of course, you can find all the ways to get in touch with us and spread the word on social media. Don't forget to leave us a review on iTunes so more people can learn of the show and get to enjoy it as well. Thanks for joining me today, Penny, Shane and Lucas.
Thanks, Ed.
No worries, thank you.
This episode was edited with barely contained malevolence by Marcos Benamu. And thank you everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
Family found. Okay, they're not going to forget this. Take a look at a photo. It looks like a normal Christmas tree, right? See anything unusual?
Zoom in.
Upper right, that's not a piece of tinsel up there. That is a tiger snake slithering around up there. Tiger snakes, by the way, are among the 10 most toxic animals on the planet. The snake catcher, Barry Goldsmith is his name, he tells us they aren't dangerous unless you try to poke them.
And then?
In 20 minutes, though, that guy had the snake in the bag. Christmas crisis avoided.
I don't want any snakes.
Do you remember this? What is that from?
Snakes on a plane.
Oh, do you remember the snake in the toilet? Remember we had that one?
Yeah.
I haven't forgotten that
And the
story.
snake on a plane recently coming back.
That's right.
The snakes have been everywhere.
Baggage compartment.